July 12, 1942, 16:20 hours. Defensive position, 15 miles west of El Alamein, Egypt. Corporal Thomas Mitchell crouched behind his Vickers machine gun, watching German infantry advancing across open desert approximately 800 yards distant. The attack was methodical, small groups moving between cover while MG-34 teams provided suppressive fire. Mitchell had seen this before. The Germans would advance until British defensive fire forced them to ground. Then their machine guns would fire sustained bursts while infantry moved closer. Eventually, they'd reach assault distance and overwhelm the position through superior numbers and firepower. Mitchell's Vickers was mounted on its standard tripod, the water jacket filled, ammunition belt fed, and ready. The gun looked absurd compared to German weapons, a massive water-cooled mechanism weighing 40 pounds without tripod, requiring a two-man crew and constant water supply. The Germans carried lighter weapons that fired faster and looked more modern. Mitchell's weapon looked like Victorian industrial equipment accidentally brought to modern battlefield. A German MG-34 opened fire, the distinctive high-rate buzz cutting across the desert. Rounds kicked up sand 50 yards short of Mitchell's position. The German gunner was finding his range. Mitchell waited, letting the German crew settle into their firing rhythm. They'd fire long bursts, pause to let the barrel cool, fire again. The pattern was predictable. Mitchell squeezed the Vickers' trigger and held it. The gun began firing with its characteristic slow, steady rhythm, roughly 450 rounds per minute compared to the MG-34's 900. But Mitchell didn't release the trigger. He kept firing. The gun's water-cooling system allowing sustained fire that air-cooled weapons couldn't match. 30 seconds, 1 minute, 2 minutes. The Vickers kept firing, each round precisely placed, the gun's stability and slow rate allowing accuracy that rapid-fire weapons sacrificed. The German MG-34 went silent. Mitchell kept firing. The German gunner was changing barrels, standard procedure after sustained firing that would melt an air-cooled barrel. Mitchell traversed slightly, engaging a different German position, still firing continuously. 3 minutes now. 4. The ammunition belt fed smoothly through the gun's mechanism, each round chambered, fired, ejected with mechanical perfection that decades of refinement had achieved. Mitchell's loader, Private Davies, changed ammunition belts without the gun stopping. They'd practiced the drill hundreds of times. 5 minutes of continuous fire now. 6. The water in the cooling jacket was boiling, steam rising from the condensing can, but the gun's mechanism remained cool enough to function perfectly. 7 minutes. 8. The German advance had stalled completely. Infantry couldn't move under sustained accurate fire, and their machine guns couldn't suppress Mitchell's position because they had to pause for barrel changes while the Vickers simply continued firing. 9 minutes. 10. Mitchell finally released the trigger, not because the gun had malfunctioned, it hadn't, but because the German attack had broken completely. The enemy was withdrawing, leaving several dead in the sand, having failed to overcome defensive fire from a weapon they'd been taught to dismiss as obsolete. Mitchell's section commander approached the position, examined the Vickers, and noted the obvious. No jams, no stoppages, no failures. Good work, Mitchell. How many rounds? Mitchell calculated quickly. 10 minutes at 450 rounds per minute, roughly. About 4,500, sir. Any problems? No, sir. Gun's fine. Need to top up the water jacket and reload ammunition, but the weapon's operational. The section commander looked at the Vickers with the affection soldiers develop for equipment that keeps them alive. The Germans think it's obsolete. Let's not tell them otherwise. The Victorian legacy. The Vickers machine gun had been adopted by British military in 1912, based on Maxim gun design from 1884. By World War II standards, the weapon was ancient, a mechanical system designed when Queen Victoria still ruled, when aircraft didn't exist, when warfare meant massed infantry attacks against prepared defensive positions. The gun reflected Victorian engineering philosophy: overbuilt, heavy, designed for indefinite service life through quality materials and precise manufacturing. The design was mechanically conservative. Water cooling, using a jacket surrounding the barrel filled with water that absorbed heat from sustained firing, was heavy and complicated compared to air-cooled systems. The gun required constant water supply, adding logistical burden. The tripod mount was massive and stable, but also heavy and awkward to move. The entire system weighed over 50 pounds without ammunition, requiring a two-man crew minimum and preferably three for sustained operations. Modern German machine guns had abandoned these complications. The MG-34, introduced in 1934, used air cooling, could be fired from bipod or tripod, featured much higher rate of fire, and weighed substantially less than the Vickers. The MG-42, entering service in 1942, was even more advanced: 1,200 rounds per minute, quick-change barrel system, simplified manufacturing that allowed mass production. Both German weapons looked sleek, modern, efficient. The Vickers looked like museum piece. German propaganda seized on this contrast. British weapons were portrayed as obsolete relics from previous war, proof that British military was unprepared for modern conflict. The MG-34 and MG-42 represented German technological superiority and innovative design thinking. British soldiers, using weapons from Victorian era, demonstrated that Britain was a backward nation, clinging to outdated methods while Germany embraced modernity. This narrative was superficially convincing. The Vickers did look obsolete. It was heavy, complicated, and slow-firing compared to German weapons. But German propaganda missed something essential about Victorian engineering philosophy. Reliability mattered more than innovation, and weapons that worked continuously under all conditions were more valuable than weapons that worked better under ideal conditions but failed under stress. The German assessment. German soldiers encountering British defensive positions supported by Vickers guns initially dismissed the weapons as antiquated and ineffective. The slow rate of fire, roughly half the MG-34's rate and a third of the MG-42's, suggested limited suppressive capability. The weapon's bulk and complexity seemed to violate modern design principles favoring mobility and simplicity. These initial assessments changed rapidly when German infantry experienced sustained Vickers fire in combat. What appeared to be slow rate of fire was actually optimal rate for sustained accuracy. The gun's stability meant that each round went where aimed rather than dispersing wildly. The water cooling that seemed like unnecessary complication allowed continuous firing that air-cooled weapons couldn't match. Obergefreiter Hans Weber commanded an MG-34 team in North Africa and recorded his evolving understanding of British machine guns in letters that survived the war. An early letter from May 1942 expressed typical German confidence. The British use ancient water-cooled guns that belong in museums. Our MG-34 fires twice as fast and weighs half as much. Their outdated weapons demonstrate why they lose battles. A later letter from September 1942, after months of desert combat, revealed changed perspective. The British Vickers gun is more dangerous than we initially believed. It fires slowly but continuously. We must change barrels frequently while they simply keep firing. During recent attack, British gun fired for 15 minutes without stopping. Our weapons cannot sustain such fire without barrel changes or mechanical failures. The old British gun proves more reliable than our modern designs, which is troubling admission but accurate observation. Weber's experience was typical. German soldiers learned through combat that the Vickers' apparent disadvantages were actually carefully designed features that enabled capabilities German weapons couldn't match. Slow rate of fire conserved ammunition and allowed accuracy. Water cooling enabled sustained fire. Heavy mounting provided stability for long-range engagement. The design wasn't obsolete. It was optimized for different priorities than German weapons emphasized. German military intelligence analyzed captured Vickers guns and produced reports that grudgingly acknowledged their effectiveness. One report noted, "The British Vickers machine gun represents obsolete design philosophy but demonstrates remarkable reliability under adverse conditions. Water cooling system allows sustained fire impossible with air-cooled designs. Manufacturing quality is exceptional, with tight tolerances and hand-fitted components creating mechanism that functions reliably despite age of basic design. Recommend acknowledging that older design can remain effective if manufacturing quality is maintained at high standards." The combat theaters. The Vickers proved its value across every theater where British forces fought, adapting to conditions from desert heat to Arctic cold while maintaining the reliability that defined its reputation. North Africa provided the harshest test. Desert sand infiltrated everything, clogging mechanisms and causing failures in weapons not designed for such conditions. German MG-34s required constant maintenance to remain functional, with crews spending hours cleaning sand from intricate mechanisms. The Vickers, with its simpler design and water-sealed mechanism, proved remarkably resistant to sand contamination. Crews learned to cover the gun when not actively firing, but even when sand did enter the mechanism, the Vickers continued functioning while German weapons jammed. Water supply was challenging in desert but manageable. A Vickers required approximately 1 gallon of water for cooling during sustained firing, but that gallon could be recirculated through a condenser that captured steam and returned water to the jacket. In extreme conditions, crews improvised, using urine when water was unavailable, a practice that worked adequately, though crews found it distasteful. The gun didn't care what liquid cooled it, only that cooling occurred. Italian campaign presented different challenges. Mountain warfare required carrying heavy weapons up steep terrain where their weight became serious burden. But once positioned, the Vickers dominated valleys and approaches with sustained fire that German weapons couldn't match. Rain and mud that stopped air-cooled weapons barely affected the Vickers. The gun functioned in conditions that rendered many modern weapons inoperable. Normandy campaign demonstrated the Vickers in sustained combat against Germany's best weapons. The MG-42, Germany's most advanced machine gun, could fire 1,200 rounds per minute, creating sound that British soldiers described as fabric tearing. But the MG-42 burned through ammunition rapidly and required barrel changes after several hundred rounds. The Vickers fired more slowly but continuously, maintaining pressure on German positions hour after hour while German gunners struggled with overheated weapons. Burma campaign was perhaps the ultimate test. Tropical humidity, monsoon rains, and jungle mud destroyed weapons not designed for such extremes. The Vickers continued functioning. Japanese forces learned that British defensive positions supported by Vickers guns were virtually impregnable to frontal assault. The sustained accurate fire was devastating against infantry advancing through jungle where cover was limited and alternative routes were few. The endurance testing. British ordnance testing had documented the Vickers' extraordinary endurance long before World War II, but the results were so extreme that even British authorities initially questioned their accuracy. In 1963, the School of Infantry conducted a test that became legendary in British military circles. A single Vickers gun was fired continuously to determine its absolute operational limits. The test used standard equipment, a Mark I of Vickers with standard cooling system and standard ammunition. The gun was mounted on its tripod in a test range and assigned a crew with instructions to fire continuously until the weapon failed mechanically. Failure was defined as any stoppage requiring armorer intervention to correct jams, broken components, or any malfunction beyond immediate crew-clearing procedures. The gun began firing. 1,000 rounds, 10,000, 100,000. The crew rotated every few hours to prevent human fatigue from affecting the test. The gun continued firing. Water in the cooling jacket was replenished regularly. Ammunition belts were fed continuously. The gun kept firing. 500,000 rounds, 1 million. The test continued for 7 days straight. 168 hours of continuous firing, with only brief pauses to change ammunition belts and replenish water. The gun fired approximately 1 million rounds before the test was concluded, not due to mechanical failure, but because the testing facility ran out of prepared ammunition and the barrel had worn smooth from use, making the gun inaccurate, though still mechanically functional. The final report noted, no stoppages due to mechanical failure occurred during test. Gun fired continuously for 7 days without requiring armorer intervention. Barrel wear after 1 million rounds rendered weapon unsuitable for accurate fire, but mechanism remained fully operational. Test suggests that Vickers guns' effective service life is limited primarily by barrel wear rather than mechanical durability. This extraordinary reliability stemmed from Victorian engineering philosophy that modern designers had abandoned. The Vickers was overbuilt deliberately. Every component was stronger than strictly necessary. Tolerances were tighter than modern mass production allowed. Materials were higher quality than cost optimization suggested. The gun was expensive to manufacture and required skilled armorer fitting. But the result was a mechanical system that simply didn't fail under normal operational stress. The German respect. By 1943, German military doctrine included specific warnings about British Vickers positions. Training materials acknowledged that the old British gun was more dangerous than its antiquated appearance suggested. German infantry were instructed to avoid direct assault on positions where Vickers fire had been identified, instead requesting artillery or armor support before attacking. Captured German soldiers expressed grudging respect for weapon they'd initially mocked. One prisoner, interrogated after being captured in Italy, stated, "We feared the slow British gun more than their fast rifles. The Vickers never stopped firing. When you heard that steady, deep sound, you knew the gun would keep firing until you withdrew or died. Our guns fired faster, but had to stop regularly. The British gun never stopped." Another prisoner's statement was more detailed. "The MG42 sounds terrifying and fires incredibly fast, but it stops frequently for barrel changes and burns ammunition rapidly. The old British gun sounds slow and unimpressive, but it fires continuously, never jams, and the gunners can fire precisely because the rate is controllable. In actual combat, the gun that keeps firing is more dangerous than the gun that fires faster, but must stop regularly." German military intelligence reports from 1944 acknowledged British Vickers machine gun, despite obsolete design, remains highly effective defensive weapon. Reliability exceeds all German machine gun designs. Sustained fire capability creates tactical problems that cannot be overcome through assault tactics. Recommend avoiding direct assault on positions defended by Vickers guns without adequate artillery preparation or armor support. This evolution from mockery to respect demonstrated that technological advancement didn't automatically create superiority. The Germans had developed more modern machine gun designs with higher rates of fire and lighter weight, but British had maintained older design that prioritized reliability and sustained fire capability. In actual combat, these Victorian priorities proved more valuable than modern innovation. The final assessment. The Vickers machine gun's service life exceeded 50 years, not because British military couldn't afford modern weapons, but because the Victorian design remained relevant despite technological advancement. The gun's fundamental priorities, reliability, sustained fire capability, durability, proved more important in actual combat than characteristics that modern designs emphasized. German soldiers, who initially mocked the Vickers as obsolete museum piece, learned through combat experience that the old British gun was more dangerous than their modern weapons in crucial respects. Rate of fire was less important than sustained fire. Weight was less important than stability. Complexity was less important than reliability. The Victorian engineers who designed the weapon's basic mechanism had prioritized correctly for sustained combat, even if they couldn't have anticipated World War II's specific tactical requirements. The gun's technical specifications seemed unimpressive. 450 rounds per minute compared to MG42's 1200. 40 pounds compared to modern weapons' 25. Water cooling requiring constant resupply compared to air cooling requiring nothing. But these specifications missed the essential characteristic that defined the Vickers. It worked continuously under all conditions without failure. The Germans mocked the Vickers as tin whistle and museum piece. Then they experienced sustained fire from gun that never jammed, never overheated, never stopped firing until the ammunition was exhausted. The mockery transformed into respect and eventually into fear of steady, relentless, unstoppable fire that defined British defensive positions. The Vickers machine gun outfired every German weapon for 50 years, not by being better in any single specification, but by being adequate in every respect and absolutely reliable under all conditions. In a war increasingly decided by logistics, sustainability, and material endurance, the Victorian gun that refused to break proved more valuable than modern weapons that worked brilliantly when new but failed under sustained operational stress. 50 years of service proved Victorian engineers right. Build things properly, use quality materials, accept complexity if it ensures reliability, and the result will outlast every innovation and fad that chases efficiency at reliability's expense. The Vickers machine gun was obsolete when World War II began, and obsolete when it finally left service. But it worked continuously, reliably, and effectively throughout, proving that old doesn't mean useless, and that proper engineering creates products that simply refuse to become irrelevant despite the passage of decades.